At this point, we'd like to go over a couple of general tasks that you might need to complete on a day-to-day basis, especially in a Unix or Linux management environment. So the couple of things we'd like to cover here include the management of processes. Processes are basically instances of components that run in the operating system environment. The management of these processes can become essential when processes get out of hand, cause problems, or require some level of troubleshooting. We'd also like to talk about process execution priority. And that's basically just telling us what level of priority does each process get. So some processes might be significantly more important than others, therefore we might find a need to raise the execution priority of some of those running or to be started processes. And finally, we'll talk about managing disk quotas. Users and their disk space has become a major concern over the last several years, especially when disk storage is not very cheap, such as on a storage area network or network attached storage system. You can actually get pretty expensive where the gigabytes and the hundreds of gigabytes can cost thousands of dollars. So having the ability to manage disk quotas or limit the amount of disk space users can consume is extremely valuable. So starting us off, the simple PS command or the process command will allow us to view running processes and their associated programs. Basically, it's just going to show us the process ID, which is a decimal value assigned to a running process that allows the operating system to track it. There are actually a lot of switches available, and we'll take a look at all of the available switches. The most common is the AUX, which basically gives us all processes, associated user information, and the X gives us any processes that don't have basically a controlling session or don't have a connection to the system. We also have the PS tree command, and this will basically break down each individual process and its associated child processes. And the reason that that can be important is if you're troubleshooting, say, high resource consumption, for example, it may be necessary for you to track down the originating process or the parent process that initialized that child process that might be consuming a lot of resources. So being able to track that can be pretty important. And ultimately, once you've used your PS commands and your PS tree commands, and you've come to a point where you realize a process is causing some problems, now what do you do about it? Well, luckily for us, we have the kill and kill all commands that can stop those processes. It's going to send a signal 15, basically letting it know that you need to terminate immediately. You're going to have to know the process ID, which is where knowing the PS and the PS tree commands will come in handy. So let's take a look at our Linux operating system and see what we can find out using these commands. So just our basic PS command, we'll take a look at the help file for it. Pretty small help file. You can see uppercase A is going to give us all of our processes, and there are lots of options available to you. But again, primarily we're going to stick with the AUX, which is going to give us just the information that we're looking for. Processes that don't have an owner, the user ID that'll let us know who actually owns the process, as well as all the processes themselves. So we can just do a simple PS, and it's going to show us a real high level, hey, here's what's running on your system. Obviously, it's important that bash is running, which allows us to enter commands into the operating system. And of course, PS is going to be running as well because we just initialized it. You can also see the process ID listed here, which comes in handy when you want to manipulate those processes. So to get a little bit more information, we'll call A, U, and X. And because we know that list is probably going to be pretty big, we'll go ahead and pipe that into a text editor. As you can see here, we've got a list out of the commands that actually initialized each individual process, how long the process has been running. We can see what the owning session might be, which usually if you have a question mark like this, it's actually the system itself. It's going to tell you the user that initialized that. and of course the process ID. You can also see CPU percentage utilization and memory utilization. So all of this information can be very useful when troubleshooting process issues. Now, as we mentioned, we can also do the pstree command, which will break it down for us into a tree. Everything is going to originate, let's go ahead and pipe that into less, from init, which is basically the level that the operating system is running. And if we continue to go down, you can see other things such as login bash has allowed us to spawn less and pstree, which is what we're using to view the information. And finally, if we want to kill a process, let's just do a quick view of a process that we might want to terminate, the sendmail process, which would be right here. And that's going to be process 917 for us. We'll just type in kill 917. And if we go back, unless the operating system automatically restarts it, we should be able to see that 917 is no longer running. And there you go. 917 has been terminated. So as you can see, knowing how to work with these processes can be very important for you.